Hi everyone, I am Sudashini Satyaruban from University of Jaffna, Sri Lanka. I am a PhD student at the University of Sri Jayawardenepura, Sri Lanka. It's my great pleasure to share my part of the research work at this conference. The title of the present study is Improving the Floatation of Fish Feed Pellets using Starch Gelatinization incorporated with palmyrah fruit pulp. I am one of the authors in the presenting paper. These are the contents of the presentation. First of all, I would like to talk about fish feed. Understanding the fish feed formulation and nutrient requirements are the important aspects in the aquaculture industry. When we talk about the practical diets, there are two types of practical diets. One is floating type and the other one is singing type. It almost depends on the fish feeding habits and behavior. Both diets provide more beneficials to their growth performance. However, floating diet is most preferred than the singing diet because of less wastage and conveniently observed as. Starch. It is an inexpensive energy source and it also can improve the water stability and durability of pellets. Starch gelatinization. It is an important practical property of floating and promotes the molecular intertuning of the ingredients in the feed mixture. The objective of the present study is to investigate the effect of starch gelatinization on formulation of floating fish feed. Methodology. Dietary ingredients. The table shows types of dietary ingredients and their nutrient value in percentage of dry weight. Among the dietary ingredients, fish meal and soybean flour are the key protein sources, whereas rice bran was as a carbohydrate source. Further, palmyrah fruit pulp was added as the carotenoid source. Standard methods were used to determine the nutrient value of each dietary ingredients. Formulation of diets. Diets were formulated at the three protein level 30, 40 and 50 percentage according to the double Pearson scale method. The table shows the ingredient compositions used in the present study. Starch gelatinization. Cornstarch, wheat flour and cassava were the sources used for the gelatinization in the present study. Wheat flour and cornstarch were purchased from the grocery shops. Fresh cassava was purchased from the market and peeled off. Then the peeled roots was washed and chopped into small pieces and dried in an oven at 100 degrees C for 2 hours. The dried cassava then ground into fine powder and sieved to get cassava flour. Distilled water was added to the flour and mixed well. Starch gelatinization was carried out by applying heat using magnetic stirrer. Making experimental diets. All the ingredients were finely ground and sieved. Then, appropriate quantity of all ingredients was thoroughly mixed together for 30 minutes in a mixture. While adding gelatinized starch, the distilled water slowly added and mixed for further 30 minutes. Dough were then pelletized using different molds of M1, M2, M3 and M4 in approximately 5, 6, 7 and 9 mm in diameter respectively. Then the wet pellets were steamed for 30 minutes and finally dried in an oven at 60 degrees C for 24 hours. The control diets was also prepared for each protein level by incorporated non-gelatinized starch sauce. Characteristics of fish feed pellets. There are two standard methods used for checking pellet quality. To assess the singing rate of pellets, the pellets of each diet were put in a 500 milliliter beaker containing tap water. And then degree of floatation was recorded within the time frame of 1 hour. To check the water stability of pellets, 50 gram sample of pellets of each diet were placed on a sieve and it was slowly immersed in a glass aquarium containing water for 10 minutes. The sieve was then removed and the crumples allowed to drain for 1 minute and then dried in an oven at 105 degrees C for 2 hours. Thereafter it was cooled down in a desiccator and reweighed. The water stability was calculated as the percentage differences in sample weight after reweighing and expressed as percentage loss of dry weight. Results and discussion. Overall, the pellets incorporated cassava flour showed significantly higher floatability and water stability as opposed to other starch sources. The highest floating ability was recorded for M1 pellets incorporated cassava flour, followed by M4 pellets. It was added with corn flour, whereas 0 minutes was recorded in all sized pellets incorporated wheat flour. Moreover, pellets with non-gelatinized corn and cassava flour did not float. The bar chart shows the floating rate of diet incorporated cassava flour. More than 90% of the pellets were more stable until end of the 1 hour. However, the floating rate of M3 pellets at 50% protein level was only 27% at the end of the experiment. When we consider the diet incorporating gelatinized corn starch, the stability of all feed pellets increased significantly with the increase in pellet size. Moreover, the highest stability was identified at all M4 pellets than the others. Conclusion of the present study. The first one, use of gelatinized corn and cassava flour has the potential to improve the binding ability of feed pellets incorporated palmyrah fruit pulp. The second one is all size pellets incorporated cassava flour are highly recommended for the formulation of floating feed pellets than the binding source of corn flour. I would like to express my special thanks of gratitude to Department of Fisheries and Department of Chemistry, University of Jaffna, Sri Lanka, for analysis of nutrient and cyanide content in formulated diet. This is the reference. Thank you so much for your interest and attention.